Okay, so perimeter. If I asked you to find the perimeter of this classroom, you would need to take some sort of measuring device like a meter stick or a ruler or a measuring tape, and you would need to go around the entire outside of the classroom measuring how long each wall is. So I could go start at one side, measure how many meters the outside of this classroom is, and then I would need to go against this wall. How many meters is this entire wall? I would have to do that around the entire outside of the classroom, add them all together, there would be the perimeter of this classroom. Now what about area? If I wanted you to find the area of the classroom, well, area is the space inside an object. Rather than the distance outside, like a fence, it's how much space is taken up inside. So I would want to use something like tiles. I could use a tile like this. Now these tiles are 1 inch by 1 inch by 1 inch. So if I wanted to see the area of the classroom, I could technically take this tile and see how many tiles fill up the whole classroom. So I could go 1, 2, 3, 4, 5. Now this would obviously take me forever if I was using a 1 inch tile. But what if I was able to have a tile that was 1 meter by 1 meter by 1 meter, a really big tile, and I had it on a stand and I could stamp inside, okay, 1 meter tile fits here. Then beside it, another meter tile. I could figure out how many meter tiles fit inside the classroom. If it was a really big space, like a city, I could use kilometers. How many kilometers tiles would fit inside the city? I would need a huge tile, 1 kilometer long by 1 kilometer wide, and see how many fit inside that space, but you could do that. So for area, you're thinking about tiles. How many of those square tiles could fit inside that space? And so when we're doing area, we think of squared. So this would be 1 square inch. This meter stick would be 1 square meter. And when you're doing area, how many square meters those tiles would fit inside the space? So whenever we're doing area, we think of squared. Meter squared, inch squared, foot squared, kilometer squared, could be whatever. Anyway, that's a little how do you do about area. In area, we're thinking of only 2 dimensions. In this bedroom, for example, there are 3 dimensions. There's the length from this wall to the back wall. There's the width from the front to the back. But then there's also the height from the floor to the ceiling, right? I can stand up in this space. But when we're thinking of area, we're only thinking of 2 dimensions, the length and the width. If we look at this whiteboard, there's 2 dimensions, the length and the width. We're not thinking straight up as well. We're just thinking 2 dimensions, length and width. So what I could do to find the area is I have these tiles. I could see how many tiles fill up my way. Okay, so that is 9 inches. The length is 9 inches. I could also do the width. So the length, 1, 2, 3, 4, 5, 6, 7, 8, 9. The width, 1, 2, 12. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for this whiteboard, the length is 9 inches. The width is 12 inches. So I could go and I could fill up this entire whiteboard. I could start filling up one row, 9, another row of 9, another row of 9, another row of 9, another row of 9, all across the whiteboard. So you might be getting the picture of, hey, these are groups of something. I could do one group of 9, two groups of 9, 3 groups of 9, 4, 5, 6, 7, 8, 9, 10, 11, 12 groups of 9. Or you may be someone who'd rather think of it the opposite way. One group of 12, two groups of 12, 3 groups of 12, 4 groups of 12, 5, 6, 7, 8, 9 groups of 12. So in math terms, when we think of groups of something, we are thinking of multiplication. For area, we could think of 9 groups of 12. It would be the same. Oh, that's not 9. It would be the same if we thought of it as 12 groups of 9. If we multiply those together, then we would get our area. I will let you think about it. 12 groups of 9 or 9 groups of 12. Okay, 9 groups of 12. We look at our board. 9 groups of 12. If we put 9 groups of 12 on this whiteboard, it'd fill up the entire whiteboard of tiles. 9 groups of 12 equals 108. Now the next question is 108 what? So these tiles, we could say 108 tiles is the area, but to make it more mathy, we want to say, well, these tiles are, let's see, these tiles are 1 inch tiles. So we would think of 108 inches. But it's not just one direction. We're thinking of length and width. So we need to say 108 inches squared. So 9 groups of 12 would fill up that entire whiteboard. 9 groups of 12, 9 times 12 is 108 inches squared. These are square tiles, so we're thinking squared. So I could do that with this room as well. Instead of using these 1 inch little tiles to see the area of this spare bedroom, that would take me forever, placing them out all the way along one wall, placing them all the way out another wall, seeing how many groups that would take up. That would take so long. So instead, I could take my tape measure. Let's do that right now. So I'm going to start with my tape measure at one side of the wall, take it all the way across. So for this room, it is 12 feet wide. Let's write that on the whiteboard. 12 feet. Now I need to measure the width. Let's do that together as well. So I start all the way at one side of the room. By 14 feet long. Let's write out that on our whiteboard. So this bedroom that I'm sitting in is 12 feet long by 14 feet wide, or 14 feet wide by 12 feet long. It doesn't matter which way you say it. And my tiles in this case are not little inch-long tiles. Instead, I'm thinking of foot tiles. Tiles that are 1 foot by 1 foot, not 1 inch by 1 inch like we did with this whiteboard. That'd be too small for this room. Feet would make more sense. So I could go, and I'm sure around my house, actually I think I do. I'll be right back. Haha. So these are some old floor tiles that have been sitting in our house since we moved in, and these floor tiles are 1 foot tiles. These tiles are 1 inch tiles. These are 1 foot tiles. And for the purpose of this bedroom, it'd make more sense to use a foot tile, foot squared, rather than an inch squared. So what I could do is I could go around and I could see how many tiles fit in this room. How many foot squared tiles fit in this room. I've already measured. 14 would go along one side and 12 would fit along going the other side. So what I would need to do is see how many groups of those. So if we look at our whiteboard, so in this one I'm pretending that there are 14 foot tiles that would fit along one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Obviously those aren't perfect, but you get the picture. 14 foot tiles, 14 feet along one side, and 12 the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one counts as 12. Can't forget that. So in this case, I'm thinking 12 groups of 14. 12 times 14. So you could look that up right now. You could do it online or whatever. On 12 groups of 14. 12 times 14 is 168. 168 what? Remember, it's not inches this time. We are using feet. 168 feet, but we're not done yet. These tiles, in the case of this bedroom when we're using feet, these tiles, we're thinking squared. These are square tiles, so 168 feet squared. That would be our answer. That is the area of my spare bedroom that I'm working in. I could fit 168 of these tiles laying down on the floor in this bedroom. Again, this is only 2 dimensions. We're not thinking up and down. We're just thinking length and width, not height. So an area, we're thinking squared because we're using square tiles, whether they be bigger tiles like this or smaller tiles. Technically, we could get even bigger tiles, like a meter tile. If we're thinking super huge, like the area of a country or a city, we could get kilometer tiles. So it's whatever's best for the job. This little whiteboard, it was best to use small tiles, like these inch squared tiles. For the bedroom, the best for the job was foot squared tiles. For the area of Kamloops, we might choose to use kilometer squared tiles. So that's area, the space inside something, and we can use multiplication to do it. 12 groups of 14, because we're thinking of groups going all the way across our space.